So what is the quotient rule of differentiation? So the quotient rule of differentiation is used when we're asked to find the derivative of a function that looks like this function here, h of x, where we have one function being divided by a separate function. So naturally the goal of this video is to erase this question mark and find what h prime of x is, or what the derivative of h of x is. So the quotient rule, right, written out in full, is going to be f prime of x, or the derivative of the top, times the bottom as it is, or g of x, minus the top as it is, times the derivative of the bottom, so g prime of x. And then that's all going to be divided by the bottom squared, so g of x squared. And that's the quotient rule of differentiation. So let's look at an example. So here we're given f of x equals 2x cubed minus 3x squared plus 2 over x squared. So because we see that that we're dividing one function, right, by another function, because we see we're dividing it, we know we're going to have to use the quotient rule. So we can rewrite the quotient rule over here. H prime of x equals f prime of x, right, or the top, so we'll call this top f of x, and we'll call this bottom g of x, right? So h prime of x equals f prime of x times g of x minus f of x times g prime of x. And then we're dividing all of that by the bottom, right, g of x squared, so g of x squared. So now we can take this top function, f of x, right, and this bottom function, g of x, and we can plug them into this equation right here. So f prime of x, the derivative of the top, is going to be 6x squared minus 6x, and then the 2 is cancelled, it's just 0, right? The derivative of any constant is 0. So we have 6x squared minus 6x, and then we're multiplying this by the bottom as it is, right? It's by g of x. So times x squared, and then we're subtracting the top as it is, or f of x. So that is 2x cubed minus 3x squared plus 2 times g prime of x, or the bottom, squared, differentiated or derived, right, g prime of x. So the derivative of this is just 2x, so we're multiplying this by 2x, and then we're dividing the whole thing by g of x squared. So g of x, or the bottom, is x squared, and then squared. So now all we have to do is just start canceling, or distributing and canceling. So if we distribute this x squared to both of these terms, we get 6x to the power of 4 minus 6x to the power of 3. And then if we distribute this 2x to all three of these terms, we get minus 4x to the power of 4, and then plus, right, because this is negative, so plus 6x to the power of 3, and then minus 4x. And remember, we're dividing this whole thing by x squared to the power of 2, which is just x to the power of 4. And now we see that there's a positive 6x cubed and a negative 6x cubed, so those two terms are going to cancel. And then the 6x to the power of 4 and the negative 4x to the power of 4 can combine into 2x to the power of 4, and then we're subtracting 4x, and we're dividing by x to the power of 4. And since all of these terms have an x in them, we can cancel out one of those x's, and we can rewrite this as 2x cubed minus 4 all over x cubed. And that is our final answer. So f prime of x, right, is equal to 2x cubed minus 4x, or minus 4 over x cubed. So here's another problem. You can go ahead and pause the video and use the quotient rule to try to find f prime of x. Okay, so f prime of x, or f of x, sorry, is equal to x squared minus 2x over x plus 2. So we have to remember the quotient rule is going to come into play here because we're dividing two functions, right? We have the top function and the bottom function, and we're dividing them. So we're going to have to use the quotient rule if we want to differentiate it. So the quotient rule, right, is, well, I'll use top and bottom, right? This is the top, this is the bottom. We have top prime times bottom minus top times bottom prime over bottom squared. So here we have top prime, right, 2x minus 2 times the bottom as it is, so x plus 2, minus the top as it is, or x squared minus 2x, times the bottom prime, which is just 1. And then we're dividing the whole thing by the bottom squared, so x plus 2 squared. And now we can start distributing and canceling terms. So if we kind of FOIL this, we will get 2x squared minus 2x plus 4x minus 4. And then over here we have minus x squared minus 2x. And then it's all over x plus 2 squared. Then we can look back at the top for anything we can cancel. So we have minus 2x, and this should be plus 2x, right? Because minus negative. So we have minus 2x and plus 2x. So we can cancel those. And then it doesn't look like there's anything else we can really cancel. It's just things we can combine. So 2x squared minus x squared is just x squared. So those are done. And then we have plus 4x, so plus 4x, and then minus 4. So we got all the terms on the top done. And now we have the bottom, x plus 2 squared, and, or x plus 2, whoops, x plus 2 squared. And it doesn't look like there's anything we can really cancel there. Even if we factor this out, it doesn't look like there's going to be anything really that we can do. So our final answer is f prime of x is equal to x squared plus 4x minus 4 over x plus 2 squared. So if you got that as your answer, good job, you got it right. So here's another quotient rule practice problem. This one's a little more complicated, but go ahead and pause the video and try it out if you want to. Okay, so the first step when you're given a problem like this, I think it's important to kind of underline or highlight or circle the important information. So what we're being asked to do is find the slope of the tangent line. So the slope of the tangent line is the same thing as the derivative. Those terms are interchangeable. So we're really just being asked to find f prime of x, right? That's what we're trying to find. So the slope of the tangent line, and it's drawn to this graph. So this is our f of x, and it gives us a point, right? So when x equals pi, so that means we're going to have to plug in pi after we find our derivative to find the tangent line at the point that they want us to find it at. So let's start by finding the derivative of our function, which is f of x equals 3x over cosine x. So we can use the quotient rule, right, because we're dividing two different functions. So the derivative of the top is 3, and the bottom as it is just cosine x, and then we're subtracting 3x, and then the derivative of the bottom. So the derivative of cosine is negative sine of x. So negative sine of x times 3x. And then we're dividing the whole thing by the bottom squared. So cosine x squared. So now what we can do is kind of just multiply this term right here out. We don't really necessarily need to, because we could just plug in pi, but I think it'll be beneficial to just plug this in, or to simplify this, so that we can have something that's a little easier to work with. So after we simplify, we have 3 cosine x minus, or it's actually going to be plus, right, because minus negative, so plus 3x sine x, and then the whole thing is divided by cosine x squared. So now what we're going to want to do is plug in this pi for x. So this is kind of the notation here that you would write on a FRQ on the AP test or anything. You just draw this line and then x equals pi. Or if you had a y value that you're plugging in, you'd also write y equals whatever. But this is the notation that you do. So we draw this line and we write x equals pi. So we have 3 cosine pi plus 3 pi sine pi over cosine pi squared. So cosine pi, right, on the unit circle, it's not a great unit circle, but we have pi right here. Cosine at pi, right, x at pi is -1. So we have 3 times -1, so that's -3. And then sine pi, right, so sine at this point is 0. So this whole thing is just going to become 0. And then that's divided by cosine pi squared, so cosine here at this point, -1 once again. And -1 times -1, right, -1 squared is just +1. So this is going to be equal to -3. So the slope of the tangent line of this graph at this point is -3. So if you got that answer, good job. Okay, here's another example. This one's even more complicated, but it's still not too hard. So you can go ahead and pause the video and try to use the quotient rule to answer this question. What is the equation of the tangent line of f of x when x equals -2? Okay, so there's 2 things that you need when you're trying to find the equation of a tangent line, or the equation of a normal line, or anything like that. You need the point of tangency, or the POT. Let's do it in black. You need the point of tangency, right, or the POT, and you also need the slope of the tangent line, or the SOT. So we'll worry about the SAT after we figure out the POT. So the point of tangency, it tells us that x equals -2, so we already know x equals -2. And if we want to find the y value when x equals -2, we're going to have to plug -2 into this equation, right? Make sure you don't differentiate it first. Plug x equals -2 into the original f of x equation. So if we have f of -2, right, we'll do f of -2 equals 2 times -2 minus 1, or 2 times -2 minus 1, over -2 plus 3, which is equal to -4 minus 1, which is -5, and -2 plus 3, which is 1, so it's equal to -5. So our point of tangency is going to be 2, -5. And then the next step is finding the slope of the tangent line. So the slope of the tangent line, which is the same as the derivative, right? This is the same as f prime of x, or in this case, right, because x equals -2, this is actually f prime of -2. So let's go ahead and find the derivative and then plug in x equals -2. So f prime of x, using the quotient rule, is the derivative of the top, or just 2, times the bottom as it is, minus the top as it is, or 2x minus 1, times the derivative of the bottom, which is just 1. And then that whole thing is divided by the bottom squared, so x plus 3 squared. And then what we can do from here, we don't really need to simplify anything. We can just plug in our x equals -2. So we're going to write this line, and then x equals -2. And we're going to plug in -2 for all the x's. So if we plug in -2 here, we get 1 times 2 is 2, and then minus, plug it in here, we get negative 4, minus 1 is negative 5, times 1 is still negative 5, but it's minus negative 5, so it's plus 5, and then it's divided by, plug in negative 2 here, we get 1 squared is 1, so that's equal to 7 over 1, which is just 7. So the slope of the tangent line, right, or f prime of negative 2 is equal to 7. So the slope of the tangent line is 7. So now to write our final equation, write it in green, our final equation, we can use the point slope form, and we can write y plus 5, right? So y, or actually I'll write out what this form looks like. It looks like this. Y minus y1 equals the slope, right, or m, times x minus x1. So write the final equation in green. We're going to have y minus our y value, which is negative 5. So minus negative 5 is plus 5. And then it equals the slope, so 7. Let me make this 5 a little more, like a 5. So we have y plus 5 equals 7 times x minus our x value, which is negative 2, so x plus 2. And this is our final answer for the equation of the tangent line of f of x when x equals negative 2. So if you got this answer, good job.